Következik most James Larmer, aki New Yorkból érkezett hozzánk. Ő egy mesterséges intelligencia részlegvezető a PricewaterhouseCoopersnél. James.
Okay. Hi, everybody. Hi, my name is James. Just to shift the mood slightly, can I just see your hands real quick? All right, make the number 4 with one of your hands, make a gun with the other. All right, good. Okay, so the next few minutes we're going to be changing a few neurons, so I just want you to swap it, and swap it again, please, and swap it one more time. Okay, good stuff. Okay, so Zia to everybody, Igen, Egészségedre. This is all the Hungarian I am aware of. Köszönöm. Okay, thank you for being here. And it's a pleasure to be here with so many old friends. Thank you for your kind invitation, Ákos. And congratulations to the entire Human Telex family for your 30th birthday celebration. So the number 30 has been on my mind ever since Ákos said he wanted me to teach everybody in this room everything about AI. And luckily we have 30 hours to do it, okay? So we're going to take some breaks. You'll have a good night tonight. Come back tomorrow. We'll have an 8-hour session. So just for the next 3 or 4 days, we'll be talking about AI. If that's okay with you, Ákos? No, he's telling me I've got 15 minutes. Okay, so what the heck? AI. 30 things to know about AI. Let's just see if we can get some technology working. Here we go. 30 things to know. This is going to be quick. So, first thing is, what the heck is AI? So AI is the ability of a machine to perceive its environment and then perform some sort of task that you would normally associate with a human. And we know from our own research that AI has expected to have huge benefits over the next 30 years, right? So by 2030, we expect a $15 trillion impact to global GDP just from AI. And that's from both amplifying business through increased productivity, is through new products and services, either driven by or enabled by AI. And generally, AI, for sure, is generating a lot of excitement. I mean, so much so that Jack Ma, the founder of Alibaba, confidently predicted that 30 years from now, that AI would feature on the cover of Time. Is there such a thing as a cover of Time in 30 years, even now? But would feature on the cover of Time as the best and most powerful CEO. A lot of AI hopes. It's interesting though, it hasn't always been this way. If we just rewind 30 years, right? 30 years ago, just as tremendous waves of change were affecting Europe and Central Europe, perhaps triggered by events in this very country, AI was entering what we would call a second winter. And the second winter was caused by a drying up of funding, particularly from DARPA. And DARPA is the big US defense agency that provided a lot of funding for research for 30 years prior to that, right? So that drying up of funding was caused by a lack of real excitement about what AI was, right? But a couple of other things were happening in 1989. I mean, the fall of the Berlin Wall, of course, the founding of this Hungarian enterprise called Human Telex. But I'm thinking, of course, of this landmark paper by IBM, which really transformed for the next generation, thinking about AI as being a probability-based approach, being less of a rule-based approach and more of a probability-based approach. It was also transformed by this guy, a little guy called Tim Berners-Lee, who submitted a proposal to CERN because he was looking for a little bit of funding to invent something we now call the internet. So you fast forward a few years and AI starts to get a lot of attention. First in 1997, when Deep Blue beats Garry Kasparov in chess. And why is that important? Well, AI was sort of involved, but that success was born out of pure brute force. Deep Blue could evaluate 200 million different moves in a second. Garry Kasparov could handle about 50. If we fast forward to 2011, this is when AI won Jeopardy and $1 million to boot, And that was significant because the concept of a computer beating humans at language-based creative thinking was unheard of at that time. And then in 2016, we reached this new milestone. 2016, by the way, was only 3 years ago. In 2016, we reached a new milestone when a neural network model called Alphago beat Lee Sedol, the World Go champion, in a couple of games. And what was the big deal there? Well, first of all, Go is an incredibly complicated game. In chess, there are probably about 400 opening moves. In Go, there are about 100,000, just in the opening sequence. And that meant you needed a system that could be trained, not coded, and that's sort of been the recent breakthrough in AI over the last several years, through the power of deep learning and the power of neural networks. By the way, just 1 year later, Google created something called Alphago Zero, and Alphago Zero beat Alphago, right? That was 1 year later. And by the way, it did it with only 4 hours of training by itself, with no instructions. That is the power of deep learning today, particularly in closed systems like that. So here we are, 30 things to know about AI. And there will be a test at the end of this, but just if you could all write these down, remember them, and sequence them. This is all you need to know to be an expert in the field. And of course, we're not going to go through all of this. We're not going to be foolish enough to try that in 11 minutes. But yeah, we're going to do that, because that's the kind of people we are, people. Okay, so we are benefiting, obviously, from 60 years of experience. The first thing to know is this combination of computing power, this convergence of algorithmic advances, data proliferation, and obviously this tremendous increase in computing power and storage, both has propelled AI from hype to reality, as well as driven a lot of the work and the advances that have happened in AI. So we're benefiting from 60 years of advances that include exploding data created from not only the invention of the internet, but the things like the launch of YouTube, the things like the launch of Facebook. These iPhone devices we carry around in our pockets are unleashing enormous quantities of data that's feeding off that computational power to deliver sort of the results that we're looking today. So the computational power was predicted by Gordon Moore, of course, back in 1965, and Gordon Moore postulated that computational power would double every 18 months. And if you follow that trajectory, you start to get some pretty impressive results. My favorite example is this guy, the ASCII Red. ASCII Red, it was introduced in 1996. It cost $55 million. It was the size of a couple of tennis courts. But it reached, in 1997, a remarkable feat. It calculated 1.9 teraflops of speed, right? 1.8 trillion floating points per second of speed. If you think of Moore's law, just in 8 years, another computer came along that reached the same level of speed. Any idea what that was? It was this guy, Sony PlayStation 3. Same level of speed, happened within 8 years, a fraction of the cost, a fraction of the size, a fraction of the energy efficiency. Fast forward a few years, and now let's talk about the IBM Summit, the fastest supercomputer in the world. Merely cost $325 million, it's the size of 2 basketball courts. But if you look at the speed, we can now do 200 petaflops of speed. 200, that's 1,000 times greater than the speeds that we existed just a few decades back. So we tend to think of AI, if we go to sort of the next 3, right? We tend to think of AI, the way we like to talk about it is about sensing, thinking, and acting, right? So sensing covers AI's ability to extract and generate language, as well as see and understand images, like a cat. It was a big thing back in 2011. And voice, like Siri and Alexa, although Siri didn't understand my Hungarian today when I tried it. Thinking, particularly machine learning, is really a driving force of AI, as well as deep learning. And acting refers to a whole class of fields, but probably the most prolific right now is robotic process automation. And this has been a big feature over the last several years, robotic automating repetitive tasks that are happening in the field. So, all of that is underpinned by all sorts of boring stuff that you studied back in university. So if you didn't like statistics, if you didn't like complexity theory or game theory, then you probably didn't grow up to be a data scientist. My guys love this stuff, right? So we keep going. We're up to number 11. 5 clear classes of machine learning. Now this is the driest part of this talk, but let's try and make it interesting, right? So AI is powered by machine learning. What the heck is machine learning? Machine learning is basically breaks down into, we've got 5 here. Let me show you at least 3. 3 types of machine learning. Machine learning, very much like a kid, is either supervised, unsupervised, or you do reinforcement learning. And I apologize to the interpreters for trying to cope with this, right? So supervised learning is essentially like teaching a child to sort colored Lego blocks by giving them a destination. They know where the blocks have to go. Unsupervised learning is essentially you say, kids, here's a bunch of Lego blocks, do what you will with them. And some will sort them into colors, some will sort them into shapes, some will essentially make all sorts of patterns, some will throw them away, some will eat them. Reinforcement learning, of course, is when the parent is in the room, right? When a parent is trying to give some sort of instruction. So machine learning, just to make it simpler, breaks down like this, right? All sorts of supervised learning on the right side. For you to be an AI expert, all you need to know is to say regression and classification. Regression and classification. Regression is all the stuff we wake up to every day when we stare at our iPhone and try and figure out what the weather will be, or when we use our iPhone to predict where we need to drive in order to get to symbol, right? Classification has to do with the ability to understand, is something yes or no, is something bad or good. It's used all the time, of course, by banks in trying to protect us from credit card fraud. Supervised learning, you guys are good at that. Okay, unsupervised learning, this is non-labeled data, self-organizing, right? This is where the real power has occurred over the last couple of years. We have dimensionality reduction. You know, this is more about big data visualization and compression. Don't worry about that. What you really need to worry about is clustering, right? So AI unsupervised learning is a powerful tool that we use, that Human-Telex uses, to understand its customers. How do you break down? How does this room break down into different types of groups, for example, right? Unsupervised learning, okay, got that? Good to go. Now, we won't get so crazy as to talk about reinforcement learning, but let's talk about these cats for a second. Because you did so well, right? The basic idea that Herbert Simon and others had around deep learning is that as much as humans learn from experience, AI needs to be able to learn from experience. So in 2011, the first computer system did exactly that. When without any instructions, it figured out what a cat was. And that doesn't seem like a big deal to us because we learned that within a few moments of being a kid. It was a very, very big deal for AI. And the way it did that is it used a many-layered feed-forward neural network that was effectively trained one layer at a time and then fine-tuned using something called backpropagation. And backprop, as it's affectionately known, allows a neural network like this to adjust hidden layers in the event that the output it comes up with doesn't match what the owners expect of it. What's interesting about this for me, and this is this shift from coding to training, is the system is starting to operate more and more like a human brain. The way we learn is by reinforced behavior. Our neurons fire, connections are made within our brains, and that's how we learn to not touch the hot stove, for example. AI is learning in a very, very similar way. So neural networks essentially was revived and helped revive this AI winter, and deep learning is now used to drive incredible performance, particularly over the last few years. This is an example from our lab, just some of my team playing with a deep learning network. And we're just using it to identify moving images in real time. We're not typing any code into this. So it can figure out that this is a bird, for example, right? It can use to figure out that that's a bird, something else coming up might be a bike. We can figure out what an airplane looks like. And all of that, of course, is feeding into our ability, an increased ability to do driverless cars, for example. It is impossible to code a driverless car. It has to figure it out on its own with some degree of guidance and training by humans. The real question, though, is what would you need to trust a complete driverless car without any humans? What would you need to trust an airplane that had no pilots in the front of the seat? Which brings us sort of to the next area of AI, which is around the risks of AI, right? And we think of them sort of as business level risks, and we think of them as kind of what I would say is national or societal level risk, right? So performance risks is the first of the business ones. Performance risks arise when an AI is so complicated it essentially has become a black box, or it's been trained on biased data. And we're seeing this increasingly an awareness, particularly from Europe through some of the regulations here, to understand that what you feed into the system is what comes out of the system. So this is an example of us trying to predict recidivism, right? The likelihood to re-offend. And you can see here on the left and right, given a certain kind of crime, is this person likely to re-offend? And the AI always says the black person is going to cause more problems in the future. And why does it do that? It's not because the AI is biased, but because the data that's gone into training it is based on real-world examples. And unfortunately, in the US, we tend to jail a disproportionate number of black people, right? So those biases are creeping into all of our AI engines, right? As we embed AI in our daily lives, we also have to manage increased security risk from bad code or from data privacy breaches, but also from what we would call adversarial attacks. Today's image recognition systems, for example, can be easily fooled. So for example, if I put some tape in strategic places on a stop sign in the US, the AI will think it's a 60 zone and will speed up the car. What kind of risk does that pose? And how do we cope with that? There is control risks, where, for example, in 2010, one single trade triggered an AI-driven sell-off that wiped out 1,000 points from the stock market. And that all happened in 15 minutes without any humans being able to intervene in that technology. And then briefly, and it's sad because this is probably the most important thing for all of us, is these national risks that need to be addressed by AI as a community. There's the ethical risk, which is, machine learning, yes, it's using some code, but at some point it needs to make a decision. If a car is out of control, does it kill one person crossing the street legally, illegally, or does it kill two people who are crossing the street illegally, right? Now, even humans can't decide those kinds of ethical questions, and that's become an increasing study of field in universities. How do we embed our values inside AI? There are real economic risks. We're continuing to automate large portions of our workforce, for example. How are we training the future generations? How are we helping folks migrate to new technologies? Now, we've seen this throughout history, from horse-driven buggies to cars, from steel factories to offshoring, for example. But those risks are definitely being imposed by AI. And then there's societal risk, right? AI becoming embedded in weapons. AI becoming embedded in a lot of hacking that we've seen, maybe in recent elections, for example, as well as this sort of societal risk of AI creating an even greater intelligence divide between the haves and the have-nots. These are things that we have in mind, but there is hope, right? How do we take advantage of the power of AI while doing it responsibly? So we think there are 6 things to do, and maybe I should let the machine tell us. Brings us to the 28th set of things that you need to know about AI and what else is on the horizon. And that is all about convergence, right? So for example, extended reality, for example, is bringing together AI and IoT and virtual reality technologies to, for example, enable new ways for us to train our staff. We use it now at PwC in training HR professionals. We're seeing interfaces become much more ingrained and immersive for us. We no longer need to type in our password, for example, into our phones. We can use our thumbprint, we can use our face. We're bringing together a host of technologies powered by AI to transition manual processes to digital ones. Intelligent automation, for example, is enabling our staff to shed a lot of unwelcome admin. I work in an accounting firm. We read a lot of tax notices. AI can read that stuff. We're using it for digital reflection. We've created a lot of virtual worlds, replicas of the real world using AI, and it enables us to test countless different scenarios that would be very difficult in the real world. And finally, all of that power is increasingly being put to the edge, right? Meaning that we're embedding AI where real life happens. The ability of a room to understand you when you walk into that room. The ability of an AI device, whether it's on an oil pump in Alaska or whether it is on a monitor inside your heart, to make a decision that will save your life or will fix a pump in real time without human intervention. Those kinds of advances are increasingly being embedded in places like hospitals, for example, where AI and IoT is being embedded. This is from our friends at Microsoft. Is being embedded in the way patients go through an experience. Who's in the room using image recognition? What's the kind of equipment that they use? What did they say? Can we diagnose what went wrong or what went right in a procedure? Just by surrounding those folks with intelligence and more virtual in technology. So, just to finish up, we're up to 29. 29 things to know about AI, and hopefully we can switch here.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or, how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you. Stay woke, bitches.
So we live in a scary world. We live in an exciting world and a little bit of a scary world. And we're going to be dealing with deep fakes for a few years yet until we learn to figure out how to navigate that world. You know, who's worried with an US election coming up, right? So 29 things about AI. So there's just one more, right? And when I think of AI, I think of this. A global-minded force of young people who, for over 70 years, have been developing young leaders and allowing them to dream big, to make big mistakes, and open their minds to a wonderful world. So, great to see you, England, Michelle, Alfredo, Stuart, Anthony, Kent, sorry you were not here, and Arkosh. Thank you for bringing the team together. Congratulations on your 30 years, and good luck.